Hello, everyone. Welcome back. I'm about to go over this question with you guys because I know there were some issues with it. So this particular question is asking to compare interest earned on a simple interest account versus a compounded interest account. So over here, you've got Donna who deposits $30,000 into an account that pays 3% interest per year, and it's compounded annually versus Tony, who deposits $30,000 into an account that also pays 3% per year, but his is at simple interest. So your job is to find the interest Donna and Tony earned during each of the first 3 years, then decide who earns more interest for each year. Assume there's no withdrawals and additional deposits. The first thing I want to mention is this, guys, the columns. Okay, now this one right here on the right side, we have Tony, and the one on the left is for Donna. It switches from time to time, so I just want you to be aware of that. So your problem, your Tony, let me change this color over here, might be on the left, and then Donna might be on the right. So it just depends on your problem. See, Tony's on the right, Donna is on the left over here. So be careful with that. I am going to go ahead and get started with finding the interest for Tony because, guys, it's easier to calculate simple interest. Now, for this one, because it's simple interest for Tony, you get the same amount in interest every single year. And remember, guys, you're doing this for 3 years. They want to know how much interest is earned at the end of each of the 3 years. So at the end of the first year, at the end of the second year, and at the end of the third year. So to calculate simple interest, guys, we simply use our formula, our basic formula. I is equal to PRT, the principal, multiplied by the rate, multiplied by the time. And so one of the things I like to do is to convert the percents to a decimal. So our percent here is 3%. To convert into a decimal, you can either plug it into a calculator and do 3 divided by 100, or you can actually take the decimal point and move it 2 places to the left, and that will result in 0.03, okay? I prefer to use the decimal, but if you got a percent symbol on your calculator, you can use the percent symbol instead. So now, guys, that we have all this information, we can go in and calculate how much interest is Tony earning at the end of every single year for the first 3 years, okay? So the I value will equal to his total deposit of $30,000 multiplied by the interest rate, which we converted to a decimal. Actually, it's a great habit to form to convert your percents to decimals. It actually helps, okay? And then the time, the length of time is just going to be 1 year, guys. And remember, it's the same formula for every single year. You throw this on a calculator, 30,000 multiplied by 0.03 multiplied by 1, guys. And this turns out to be a total of $900. So Tony is going to earn $900 in interest at the end of the first year. And then on the second year, the same amount, because interest is simple interest is calculated on just the principal. He's going to earn the same amount because, guys, it's on the principal. The third year, it's going to be the same thing. So the interest for Tony is obviously very easy. Now, we're going to move on, guys, to calculating the interest for Donna. Now, Donna is a little bit more complicated because now you're talking about compound interest. And with compound interest, not only are you earning interest on the principal, you're also earning interest on any interest earned. So that way your money grows faster, guys, okay? So this means that when we are calculating the interest for Donna here, we're going to have to use, number one, a different formula because it's compound interest. And the compound interest formula we're going to use is A is equal to P times 1 plus the rate, which is your R, raised to the T power. Now, remember, the interest is calculated or compounded annually. That is why I'm using the simplified form of the formula. A equals to P times 1 plus r over n to the nt power. Since all the n values are equivalent to 1, this formula right here simplifies to this because it is annually. All right. Now, here's an additional point I need to make. This formula is going to help us to calculate the total account value, the amount and the account. And so because it's the amount and the account, it's going to include the principal as well as any interest earned. So we're only looking for the interest earned. So once we're done calculating the total account balance, we're going to have to subtract the original amount to figure out how much interest is earned on the first year. And we got to do the same thing for the second year and for the third year. Yeah, it's a lot of work for Donna. So let's go ahead and get started with Donna. So for Donna, guys, on the first year, we're going to do her amount that she invested, which was the 30,000, multiplied by 1 plus the interest rate. Remember, it's the same interest rate, 3%. So we're going to use the decimal for that. And it's being raised to the first power because the length of time is a year. We throw this on a calculator, guys. Seriously, plug it into the calculator. Now, the power, which is 1, guys, is moot. You really don't have to do it, but I'm still going to go ahead and show it to you, okay? So on this one right here, guys, when we plug this into a calculator, we're going to get a total of $900. So essentially, because it's the first year, it's the same amount of money as the interest, which is simple interest, when the interest is calculated at simple interest. Okay, so those two are the same. That's easy. Now, Shazam, I put the wrong thing, guys. So it's gonna turn out to, hold on a second, I left the step out. Let me just go back just slightly, okay? I'll show you how I got that 900. I'm ahead of myself just a little bit, okay? So let me go back and fix that. So basically, it is 30,900. Remember, you're supposed to be calculating just the interest. So the total balance you would get, what you would get on your calculator is 30,900 when you plug all this into the calculator. However, we only want the interest. So to calculate the interest, we're going to take the total, which is the 30,900, subtract the 30,000 we started with, and now we'll produce the 900. See, I went a little too fast there. I was ahead of myself. And so I just put that 900 there. So there's your 900, okay? So that's the first year. Now, guys, for the second year, let me go ahead and use a different color here, okay? For the second year, this person is now going to calculate the interest not on 30,000 anymore, because now the account is at 30,900. So we're going to use the 30,900 for the second year. So on the second year, I'm going to write this down over here for you guys. We're going to calculate the total amount earned, and then we're going to subtract what was initially invested, okay, after the first year. So we're going to plug in that 30,900, and then we're going to multiply this by the 1 plus, again, same interest rate, 0.03 raised to the first power. We throw this on a calculator, guys, and the total amount we get for this is 30,000. Actually, no, hold on a second, 31,000. Let me go back just a little bit. Okay, it's $31,827. Okay, so now, guys, we're not done yet. This is the total account balance. So to calculate the interest earned, we're going to take the total amount of 31,000. By the way, this is already on your calculator, so you could just go ahead and subtract what you started with. What did you start with? You started with that 30,900. And when we find the difference between those two amounts, it turns out to be $927. So for the second year, everybody, this person is earning a total of $927 in interest. Now you should start seeing that there's a difference. There's a difference between these two amounts. Why, guys? Because not only is this person getting interest on the initial deposit of $30,000, they're also earning interest on the $900 in interest they earned during the first year. By the way, did I mention that I love compound interest, guys? I love compound interest, okay? Now, we got to go to the third year. And before I erase some of this to go to the third year, guys, let me go ahead and show you what's next here. Let me see if I could slide this over. Can I slide this over? No, I can't slide it over. Okay, so to go to the third year, guys, let me change the color first and foremost, guys. Okay, I'm going to change it to black now. Okay, so guys, on here for the third year, we're not going to start with 30,000 because again, we're earning interest on the initial investment as well as on any interest we've earned. And so far, between the first and the second year, we've earned a total of $1,827. So guys, well, this is the amount we're going to go into the third year with right there. You see why this problem is so complex? That is a complex problem, okay? So keep this in mind. The $31,827 is what the principal for the third year is going to be. And let me go ahead and erase some of this so I could go ahead and write it out, guys, because I need space over here. So let me erase down here so I could start calculating how much interest this person will earn after the third year, okay? Now, be careful with this problem, guys. If your numbers seem to be exorbitantly large for some of these answers, that means that you did something wrong. Because remember, we're just looking at the interest. We're not looking at the total amount and the account. We're just looking at the interest. So be careful with that. Once you see very large numbers, oh, something's wrong, okay? So now let me go ahead and work it out, guys. So this is for the third year, guys. Now for the third year, okay, now let's pay attention. We're going to use the same formula up here, guys, okay? So we're going to do A is equal to the 31,827. How did I get this amount? This amount includes the $30,000 Donna invested, plus the $900 earned in interest the first year, plus the $927 earned the second year, okay? So those amounts added together gives her the amount that's going to be invested starting the third year. So to calculate the interest on the third year, guys, we're going to take this and multiply it by 1 plus same interest rate, 0.03, and then we're going to raise that to the first power. And then we throw this on a calculator. The total amount turns out to be $32,781.81, okay? So now, guys, wait, there's more. We got to calculate how much interest was earned on the third year. So we started out with $31,827 and we went to $32,781.81. We're going to subtract what we started with, which is the $31,827. And this turns out to be a total of $954.81. So on the third year, Donna has earned $954.81 in interest. Now, guys, look at the difference. Make the comparison between simple interest and compound interest, guys. Do you see how much of a difference it is? On the second year, that's an additional $27. On the third year, guys, that is an additional $54.81. Let me write over this again because this is looking a little messy over here. I don't know why, but it is looking a little messy, all right? So, guys, now that we have the interest for each of the 3 years, guys, we can then go ahead and make the comparison. Of course, on the first year, they're the same amount. The second year, who earns more money? That's obvious. 927, that's Donna. Who earns more during the third year? That's also obvious. That's going to be Donna as well. So, guys, you see, this was a very tricky problem, but guys, I'm sorry. Me, I love compound interest. So would you rather invest your money at simple interest or compound interest? I think I will go with compound interest anytime. Those who know compound interest, they earn it. And those who don't, they pay it. That was said by a very wise man a very long time ago. Do you know who that wise man is? Until next time, everybody, you have a good one.